Welcome. Now we're going to start talking about the unit circle, considering that, and also starting to understand this radian measure. In order for us to do that, let's consider circumference. We define circumference as 2 pi times the radius r. Now, if I were to let r be 1, and we think about a circle of radius 1, then I would have circumference equals 2 pi times 1. So 2 pi is the distance around a circle of radius 1. And that's what we're going to consider a full rotation here. So if we want to think about a full rotation, one trip around that circle, we would start at 0 on our positive x-axis, all the way around. That distance around would be 2 pi. Well, it only makes sense then if we wanted to consider half of a rotation. Half of 2 pi, that takes us to 1 pi. Furthermore, cutting that in half again, half of a half, that gives us a quarter rotation. In that situation, we would start at 0, and if we take pi and divide it in half, we get pi over 2. All right, so this quarter rotation around the circle starts at 0 and ends at pi over 2. So we've broken down, kind of these measurements on our quadrantal angles. So let's just zone in on quadrant 1, which goes from 0 degrees to 90 degrees. And I have this protractor. Normally when I'm in class, I can pull it over and show you that these measure what I say they are. But if you think about midway between 0 and 90, that is 45. 45 is half. And then these other two measures, we'll think about those. We add 30 degrees, that gets us here to 30 degrees. That looks kind of messy. Add another 30, takes us to 60, and another 30 degrees there takes us to 90. So you guys believe that these are these special numbers that we're going to use for these angle measures. Now, as we said up above, we said that 90 degrees was equivalent to pi over 2 radians. So 45 is half of 90. If I take pi over 2 and cut that in half, pi over 2 times 1/2, that gives me pi over 4. Half of 90 is half of pi over 2, which is pi over 4. And 30 and 60 are thirds of 90. So 1/3 of 90, or 1/3 of pi over 2, that's going to give me pi over 6. And similarly at 60, 60 is 2/3 of 90. So 2/3 of 90, or 2/3 of pi over 2. That gives me pi over 3. And so really, we're going to focus on memorizing this first quadrant, and we're going to have ordered pairs that go along with each of these radian measures. And then rather than memorizing the entire unit circle, we're going to know one quadrant. We'll be able to reflect it to find the other measurements. So since we know our first quadrant values, we can think about these as reflections, and that's going to be something we need to do when we are creating our unit circle. So we're going to need to count by fourths as well as count by sixths. And when I make my unit circle on my paper, I normally would go through and I would label my quarter and quadrantal angles all the way around. And then I'll go in and add my thirds. So I'm going to kind of show you how I think about this. We're going to start with 0. That was 1/4 or 1 pi over 4. Here we had 2 pi over 4. 2 pi over 4 reduces to pi over 2. Next, I have 3 pi over 4, 4 pi over 4, and 4 pi over 4. That's going to reduce to pi. 5 pi over 4, 6 pi over 4, 6/4. This reduces to 3 pi over 2. And then we have 7 pi over 4. And lastly, right here, we've got 8 pi over 4. And 8/4 is 2, so that reduces to 2 pi, just as we expected. So when I'm labeling my unit circle, I count by my fourths: 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And then I'll do the same thing with my sixths. Sixths. It's very hard to say. So we're going to start with 0. We have 1/6 or pi over 6. 2/6, 2 pi over 6. That's going to give me pi over 3. 3 pi over 6. That's going to reduce to the value I expect there, which is pi over 2. 3 over 6 is 1 over 2. Then I have 4 pi over 6. This reduces to 2/3, so 2 pi over 3. We have 5 pi over 6. Over here, I've got 6 pi over 6, and 6 over 6 reduces, so we get pi as we expect. 7 pi over 6. Right there, we have 8 pi over 6. 8 over 6 reduces to 4/3, so I've got 4 pi over 3. So that last one was 8. Now I have 9 pi over 6, and 9 pi over 6 is 3/2. So I've got 3 pi over 2. 10 pi over 6, that's 5/3, so 5 pi over 3. 11 pi over 6, and then here we get 12 pi over 6, and 12 pi over 6 is 2 pi. 12/6 is 2. Right? And so it should make sense. 3 pi over 2, 3 pi over 2. We still have our pi's at 180. All right? So you are going to want to be able to get all of these values on your unit circle pretty quickly. And for me, I think about counting by either fourths, having those 8 sections, and then adding in my sixths. So I don't do the thirds because a third is a multiple of a sixth. So on the next screen, I'm going to pull in our entire unit circle. And here we can see it doesn't fit perfectly on this screen. So I'm just going to focus on the top half here. So you, as a student, would be responsible for labeling all of your degrees, then all of your radian measures, and then an ordered pair at each of these. And as we already talked about, all students take calculus. So we use that mnemonic device to let us know information about what signs are positive and negative in each quadrant. Remember, we've already talked about this as well. Cosine is going to represent my x value, sine is going to represent my y value, and then tangent we know is sine over cosine. So let me pull in a better unit circle that kind of fits on one page. This is the one that I have typed and I use in my notes, but it doesn't quite fit in here just well. So thinking about the unit circle like this, you are going to know we've got 30 degrees, and then this is 30 degrees up off 180, 150. 45 degrees, 45 up this way, it's 135. 60 degrees, 60 degrees off of 180 is going to give us 120. Or you could say, well, that's minus 30 and plus 30, so 60 and 120. You want to be able to label your degrees. And then, as I said, I go through and I count my radians. I do my pi over 4s, so that's going to get me in the middle and on the quadrant axis for each of these. Then lastly, and this is just my personal preference, I go through and I put in my radian measures counting by sixths. So when we get all the way back around here to the start, we have 2 pi. So we want to remember A, S, T, and C. All of my trig functions are going to be positive in quadrant 1. Sine and its reciprocal function cosecant are positive in quadrant 2. Tangent and its reciprocal cotangent are positive in quadrant 3. Cosine and its reciprocal secant are positive in quadrant 4. Everything else is going to be negative in each of those respective quadrants. So if we were in class, this would be a no calculator portion of your test, would be to make all of this, to fill this out perfectly without using any aids. And then once you've filled it out, you need to be able to obviously use it. So pause the video. I'll make sure you have access to a blank unit circle that you can print out and practice with. It really, really, really is going to be to your benefit when you get to your next class in calculus and we start talking about, if I say what sine of pi over 4, you want to immediately spit out root 2 over 2. It really works in your favor, and every calculus student I've ever had has told me that if they had a trig teacher that made them memorize this, this was much easier. So I encourage you to know this unit circle like the back of your hand, or at the very least, think about your right triangle trig and create that right triangle. I personally think it's easier to just know what we're looking at here and how to get it. The other thing I want to talk about are these ordered pairs. So just like when we made that chart of 6 values, I'm sorry, it was 9 values in the chart. I said 1, 2, 3, 3, 2, 1. Everything's divided by 2. Everything has a square root in the numerator, and the square root of 1 goes away. So I fill out this quadrant and I say 1, 2, 3, 3, 2, 1, divide everything by 2, put my roots on the top. I don't need to worry about square root of 1 because it's just 1. So what I want you to notice is it translates over here. It reflects across this ordered pair. If you think about folding on the y-axis, this matches over here. The only thing that's different is my x value became negative on each of these 3. So it's not just sliding. I want you to think about folding. Similarly, when we reflect down, reflect this one to here, 150 reflects to 210. 135 reflects to 225, 120 reflects to 240. And in quadrant 3, all of the signs are negative. That ordered pair would be negative, negative for any point you were plotting. I will say that these two, 210 and 240 degrees, I see those get mixed up a lot. I see the wrong answers end up there. So just make sure you're paying special attention to that. And the same thing, you could fold this down here. 160 folds over to 300. And so just the y value becomes positive for all 3 of these. All right, so it's a matter of being able to reflect those points and then just change the sign from positive to negative or vice versa on those ordered pairs. All right, so I hope that kind of helps you understand where we're going and what we need to know, specifically in regard to developing and then in the future using this unit circle.